Good morning, afternoon. Hopefully this works. This is my second time making this video. This is our pre-lab video for the Magnesium Empirical Formula Lab. So recently in chemistry class, you guys all did the chalk lab, which was a percent composition lab where we got the part of the whole and we focused on calculations with Avogadro's number and molar mass. Our other huge skill in this chapter is figuring out the chemical formula of a substance. So we know that empirical formula is what we're going to find a lot of the time. We are hopefully right around mold day. Today's October 22nd. Tomorrow is October 23rd, unless you have this in the spring semester, which would be different. But what we'll be doing in this lab is taking magnesium metal, which is a silvery, shiny piece of metal that you've all hopefully, I think, seen in my class before. But we're going to be reacting that with oxygen to make a completely new compound. And you'll be figuring out the formula of that compound. And what we'll be doing is reacting that magnesium in air. We know it's not really just air, but we'll be seeing magnesium react with oxygen to make a new compound and finding that formula. We know it's a very, very bright light. We'll be using a very special container to do that, and that's what I'll kind of walk through in this video with you here. So just leading in, I mean, we've done empirical formula problems where you've had the percentages. We've done empirical formula problems where you've had grams. We know in my class we teach GMS, so we, with both of these situations, want to get them to grams and then simplify with moles. These have been problems on paper. We're now actually going to do some of the physical exploration of getting those grams ourselves. So just kind of highlighting again, what we'll be doing is taking magnesium and reacting it with oxygen to make magnesium oxide and finding that formula that we don't know. So that's what we're going to analytically be doing with scales and specific masses. It's important, it says in the lab, but we don't really ever want to just be burning this magnesium purely in the air for safety reasons. So I think I've done this before, but when magnesium burns in the open air, it's a very, very bright flame, and we don't want to do that for our eye safety. We'll have goggles on regardless, but the other problem would be is that right now, that's not just smoke we see there, that would be magnesium oxide escaping. So in this lab, we're going to do this reaction in a very, very, very special container that traps all of that and also allows us to be safe. So that container, everyone's going to be called a crucible. It's that little yellowy thing there, but it'll be it's a little, almost like a little pot. You'll want to make sure that you get a crucible that has a lid that fits it. We want that lid to be very, very safe for us, and then we also want our crucible to be safe and not have any cracks. So you'll want to make sure you check that beforehand, but like it shows here, we'll be using our ring stand and then our iron ring and a clay triangle to kind of hold that in place. If you kind of look at my setup here, you can adjust that clay triangle however you need to make sure that it stays there. A lot of kids don't adjust that at all, and then their crucible falls. So I kind of already showed you that demo of what that looks like, but we need to know what's going on in there in our crucible, but we also need to understand that we don't want to just do that in the open air. Okay, so digging into the lab a little bit more, and I'll kind of go through that setup there, but what you'll have when you get to lab tomorrow is your ring stand, and then we'll be able to adjust our iron ring, and we can lift this up and down to get closer to the flame. And then it'll be in we'll have a little clay triangle. These little porcelain parts, you can break these and move these, and it's really important that with that clay triangle, you adjust it so that it holds this. If it's starting to fall through there as it gets hot, that's going to be a big problem with your data. It's also very, very, very important in this lab that you understand we're going to be heating things up to very, very high temperatures. So when you go to deal with your crucible, there'll be steps where you need to open it a little bit to let oxygen in and then close it right away. You will be using either these, kind of in the picture right here, these are called crucible tongs. They are made with kind of a special notched end where you can easily take that lid off. I have a lot of kids who don't end up really liking these a ton. I've also had a lot of kids who end up taking a paper clip, like I showed up in that picture up there, and then there's this little hole in the top of the crucible lid up there, and what you can do then is use that bent paper clip to kind of lift it off and lift it back on, and a lot of kids have a lot more success with that. But we want to make sure you probably mess with that a little bit before lab so you know, and then try to make sure the person with the steady hand is the one doing that in lab. If there's somebody who's not going to be a heart surgeon and is very shaky, don't let them do that, because a lot of kids will break their crucible once we get in there. So in the pre-lab, I mean, there's a couple safety things you'll need to read over, but we're using Bunsen burners, so make sure hair and we're dressed appropriately. But otherwise, the background problem, just so we know what we're getting into, I made up that I got an old car from my grandpa. The older cars have iron on them, and my grandpa always took care of it and kept it in his garage, but now Simi has a Barbie Jeep and stuff, so I have to keep it outside. Now, what the question says is how much will the iron, which was 250 pounds in the first place, how much will it weigh later? So ultimately, we know from prior chapters, it's either going to weigh less than 250 pounds, exactly 250 pounds, or more than 250 pounds. And this little picture of horseshoes really helps us start to think about it, because we know that when we get that piece of iron that's been outside the whole time, it's not just going to be iron anymore. It's going to rust, and we might not know this, but rust is when iron reacts with oxygen to make a new compound. That rust is called iron oxide. The Roman numeral we don't need to worry about right now, but with that in mind, a lot of kids think that it will weigh less because it will react and, disintegrate. Some kids will think it weighs exactly 250 pounds because they remember from an old chapter, whatever it is before is what it is after. But you got to remember, the iron is what we have before. In the end, we have iron and oxygen. So in the end, it's going to end up weighing more. And the reason being there, whoops, I did not mean to zoom me up so big there. The reason being is, where did my camera go? There we go. The reason being is that in the end, it's not just iron anymore. Now it's iron oxide. And in our lab, you're going to start with a piece of magnesium. And in the end, you need to understand that if you do it right, you're not going to have more magnesium in the end, but the whole thing will weigh more because this has gained oxygen. So that's what we're going to be doing in lab, is analytically figuring that out. Okay, so you'll be figuring out exactly how many atoms or particles of this and how many particles of this, and what that really all leads to is moles. Okay, so read through those things, and again, you'll get about a 0.3 gram piece. So that ends up being about from your thumb to the middle of your hand. That's about how long it is, but you'll all have it out tomorrow. We'll make sure that we tear it. You can tear it pretty easily, and then you'll want to go weigh it just to make sure you're close. It does not have to be exactly 0.3 grams. It can be 0.26, it can be 0.33. We just want to make sure we have enough to react, but we also don't want to have so much that it takes forever. Make sure whatever it weighs, though, you won't write yet because you'll want to clean it. We'll talk about that in a minute. But tomorrow, when you do all this, you'll want to weigh your crucible when it's empty. You will clean it first, because if there's gunk in there and it looks dirty, some of them look dirty, but they're not. But you'll just use a paper towel and soap to the best of your abilities to do that, and then you'll also heat it. If there's anything in there we don't want, that'll burn it off, just like leftover cookies on a cookie sheet. So to start the lab, then you'll clean your metal and you'll put that in here. So that's like our whole system to begin with. Some of you will end up tearing your magnesium into small pieces, and some of you will coil it. I like to do some of each just to see what works better. You'll then react it and burn it, and it will burn in the presence of oxygen. And in the end, we're going to have a new solid product. And I didn't mention this earlier, but that video where they burned it, in the beginning, it's a solid silver piece of metal. In the end, it's going to be a fine white powder. That's one of those pieces of evidence that we've had a chemical change and a chemical reaction occur, and we've truly made something new. So when you go to do that, it'll be really, really important you know when it's done, and we'll talk about that in a minute. But otherwise, little pieces of information. We'll clean our magnesium beforehand. We don't want any impurities or old things in there. So you'll take sandpaper or steel wool and just scrub it really good. Please don't do that directly on my tables, because then you'll ruin my lab tables. But we just want to make sure that it's nice and ready to go, and as far as not having any other things it's reacted with over time in there. Then you will either tear it up or coil it, and then you'll weigh it after you've cleaned your crucible. And again, I talk about how to do that. You'll want somebody on magnesium duty and somebody on crucible duty. You'll want to make sure that somebody's really, really careful as far as the one who's controlling a lot of that heat. We never, ever, ever want to put hot things directly on the lab table. You'll all have in your community drawer what's called it's called a clay or a porcelain tile. This is for us to put hot things on. So you'll want to make sure you get that out and never ever put hot stuff directly on the lab counters. Otherwise, you'll then fill out your data table and you'll start to heat your crucible with magnesium in it. And it's important, we know that reaction isn't just going to happen. Even rusting takes, decades of years. So we'll help it out by providing heat. Like I said, some of you will, I'll assign everyone coil or tear, and that's how you'll end up putting your magnesium in there. But it's really, really important. This is a thing a lot of kids mess up. Some kids' data just ends up really sucking in the end. Once it's all clean, your crucible and your magnesium, your hands have all kinds of oil on them. We don't want that all over our stuff. It'll affect the way it reacts. So once you get it clean, try to not touch it very much more. Maybe use paper towels and stuff, but that would affect your data. So make sure we're careful of that. Otherwise, as you read through the lab, it'll say that at some point you have to take the lid off. Now, like I said earlier, you don't just want to take that lid off and see your product going up into the air. You just want to take it off, and a lot of times what I'll say is like tip the hat off just a little bit, like a kid who barely wears their hat on top of their head. Now when it does that, you're going to see something on the inside that I hope you all will get the chance to really see tomorrow. So when you go to do that, everyone, I already had one pulled up. When you go to do that, it's going to be you understand what's happening. So if we don't ever let the lid off, there's never going to be oxygen. And we want it to react with oxygen. So we do have to let that lid off. But as soon as you do that, let's get a little bit better picture here. It'll be really important when you take that lid off a little bit. Watch how there's that white glow. You want to let that oxygen in because now it's going to react, but you want to put that lid back on right away. That right there, that white smoke, that's magnesium oxide escaping, and we want all of those particles. So you'll have to let the lid off to let oxygen into there, and that's when it'll glow. That means it's still not done. If there's still silver metal in the bottom, that means you still need to keep going because we want to react all of our magnesium. So you'll be done when it's all white powder in the end, and as long as you lift that lid off and it glows, that means there's some magnesium that's still bonding with oxygen in the air. So once it's all done and you feel like it's really all done, you can be much more reckless as far as your lid being off. But as long as it's glowing, you want to be careful, and it'll talk about that in the lab. So you'll know it's fully done when it doesn't look like it did in the beginning and it's all something new. It'll be really important here, this step, number 8, you'll have to cool it for a while and take it off, and then I'll have a pipette for all of you. You'll add 5 to 7-ish drops of just distilled water. You want to make sure that it's not too hot because otherwise it'll kind of spit and shoot your product everywhere. But what that water will do is it'll decompose and dissolve any nitrides that might be in there. So nitrides we know would be coming from nitrogen. And a lot of kids wouldn't understand, but air is mostly nitrogen. The air we breathe in, of course it has oxygen, but only like 19% of our air is oxygen. Most of it's nitrogen, and magnesium would bond with that too. So we want to make sure we get rid of that and just have magnesium oxide. You'll go through some steps where you then make sure you burn off all that water because we don't want that. And then you'll, at the end of the day, make sure it's all the way heated and good. You'll let it cool, and then you'll get your data. So we should ideally know what we're looking for as far as should it weigh more or less. Reheating it, just make sure that, just in case you didn't get all the water out or something, that would do that. But otherwise, what you'll get then to turn in is the calculation. So you'll be able to calculate how much oxygen it gained, and we know that we use GMS to do our calculations. I just kind of help you set it up. I just wanted to make sure we all understood when you go and get from grams of each to moles of each, normally here we divide by X, which is the smallest number. That will always get one of them to be 1 because it's divided by itself. Now, some of you it might be magnesium, some of you it might be oxygen. It really doesn't make a huge difference, but normally what we do in class is we round one of those to the nearest whole number. So like if you got 1.09, normally we'd want to say that's probably 1. But in this lab, we're actually analytically collecting data. So I want you to make sure one of your numbers, your mole number, should be 1. But the other one I want to keep all the way to the 100th place, because that's how, in the real world, in the lab, that's how we figured things out, is being specific with our data. So you might, if you're this kid, have MG1, 1.09, and that's, again, none of these are necessarily right or wrong. I don't want to say anything specifically about them, but you also might have 1 mole of oxygen, and this might be off. But that's how in the lab we do things. We don't want to round. We want to use what data we actually got. What you'll be able to do then is calculate your percent error. So your percent error is where you figure out how far off you are from the real thing. I don't know if anyone's really stopped to think about it, but we actually, after our nomenclature test, know what magnesium oxide's formula is. So if you go on crisscross, you know what it should be. In this lab, we're going back 100 years to where we didn't know the charges and all the stuff we do now. And we're actually figuring out and doing how they did it to figure out what the charges of stuff on the periodic table is. So you'll be able to calculate your percent error. And again, we just want to make sure that we're doing a good job with that and getting better. So on the back of your lab sheet, there'll be some application questions, which are questions of what the test is going to be like. We just want to make sure we're doing a good job with that. So overall, just make sure we're being really careful with our crucible. When you show up tomorrow, someone needs to be on cleaning crucible duty and someone can get the magnesium ready. I'll probably have 1 or 2 things that I'll go through. But then we'll make sure in your lab you talk about air. Once you know what the ratio should be, we always want to, in science, be saying, well, what did we do wrong? If we did it again, what would we do better? And we'll talk about that a little bit more in class. But otherwise, this is a huge part of us taking all of our paper problems we've been doing and doing it in the lab. So watch this, take your notes, be prepared, and let me know if you have questions. Otherwise, tomorrow we'll find the empirical formula of magnesium oxide.